Guys, so today I'm going to talk about paleoanthropological dating methods. There are two main methods of dating objects. So we have relative dating and we also have chronometric dating. Relative dating is a pretty simple process. All it really is you're looking at the depth that the sample is buried in the ground, and you're comparing it to another sample to get a relative age. So for example, if one fossil is buried at 50 feet and another fossil is buried at 25 feet, then it's reasonable to conclude that the fossil buried at 50 feet is going to be older than one buried at 25. There are some problems with this assumption. The Earth's strata can of course shift during things like volcanic activity and earthquakes. So this alone can't really be relied upon completely to get an accurate age. So we have to look at other techniques. Another technique that we can use that is related to stratigraphy is biostratigraphy. And this one is pretty interesting. If you have two fossils and you can determine that they're the same species, maybe you found them at different depths, then you can determine that it is possible that those layers of sediment and those fossils were laid around the same time. So if you have one portion of Earth that's made up of hard clay and another portion that's made up of like chalky sediment, the depth of two fossils, again from the same period, may be found at different depths. And if the fossils are the same species, then it's likely that the two sediments and those fossils were laid at the same time. Another method is called paleomagnetism. And this is based on the fact that the Earth's magnetic poles have shifted over time. Today the pole is oriented north, but it hasn't always been that way. It's been oriented south before as well, and north. It's kind of gone through these changes over Earth's history. So by examining the magnetically charged particles in rock, geologists can correlate those with the sequence of past magnetic orientations. So those are the relative dating techniques. So we're going to look into the chronometric techniques as well. It's based on the fact that radioactive isotopes of some elements are unstable, and they decay to form isotopic variants of other elements. Scientists know the rate of decay, so from this they can determine the age of the sample that is collected. There's different types of chronometric analysis, and you're going to use different techniques for different materials. Hominins, for instance, the way that they date these specimens is they use something called the potassium-argon method. And potassium-40 has a half-life of about 1.25 billion years, and it degrades into argon. So what this means is that half of the potassium 40 isotope changes into argon 40 in around 1.25 billion years. So this process will continue, and it'll keep decaying into argon. And the scientists can, because of this, again, the known rate of decay, the scientists can determine the age of the specimen fairly well. But it's also important to note that this method can't be used on organic matter because it requires potassium, stuff like from minerals that come from volcanic rock. Argon is a gas, right? So that mineral needs to be able to trap the gas and the mineral lattice in order to analyze that mineral in order to determine the age. Basically, what the scientists do is that they heat this mineral, heat it pretty hot, and then this argon gas is released, and they can measure it, and this is how they date the objects. So there's other forms of dating that are based on like kind of a similar idea. You have uranium that degrades into lead, and carbon that degrades into more stable forms of carbon. A lot of people have heard of the radiocarbon dating, and that's really effective on organic material. Thermoluminescence dating, this is really cool. That relies on radiometric decay as well, and essentially there are glowing particles that are trapped in trace amounts within many stones, and when that stone is heated, the particles escape and let off a dull glow. So scientists will heat a sample up to around 500 degrees Celsius, so that's really, really hot. and then they'll measure that glow to date that object. And there's also USR and ESR. USR relies on the radioactive decay of short-lived isotopes. ESR is similar to thermoluminescence because it's based on measuring trapped electrons. These methods are typically used with either potassium, argon dating, or radiocarbon dating when they can't be used. So none of these methods alone are reliable enough to date fossils, and that's really important to remember. You really have to cross-correlate the results in order to confidently state their age. And the other takeaway from this is that relative dating should really only be done by scientists and by people from the South. If you have anything else to add that I missed, go ahead and shoot me a message. If not, then you guys have a good day. Thanks.